And without further ado, please welcome Guillaume and Pikachu on stage now.
Thank you. Oh, okay. So, hi everybody. Hi Pingu. So, we are going to present what we have been doing lately with cars, actually. So, who are we? My name is Stanislas Leger, Pikachu. I'm an IT student in EPITA, a school in France, and I'm part of EPITA's System and Security Laboratory, the LSE. I'm currently an intern at Quark's Lab. I like a lot of stuff like reverse engineering, everything that is related to cars or mechanics, and if there is something stupid to do, I shall already be doing it. And with me will be Guillaume Hayes.
Hello, my name is Guillaume. I work at Quark's Lab as a security engineer. I'm quite new to the security field, as I worked in the industry before, and I switched to the security field because it's very fun and I like to reverse almost everything. And I will give a small talk about reversing a piece of hardware that you can find in an automobile.
So, what is this talk about? This talk will be in two different parts. The first one is how to drift with any car, and it's an introduction to automotive systems, what you can do with them, and what we actually did with them. And the second part, which name is how to properly write an Amazon review, you'll see why just after, is nobody dongle, so analysis, reverse engineering, stuff like this. So first part, drifting with any car. The idea is that I'm a student, so I work at my school's lab, so I had to find a way to explain why I was bringing different cars every day at my school's garage. So the official goal was to look at how a car works, and what arises from this is, what can I do, what can one do with a modern car system? The restriction I had was that, since I'm a student, I'm poor, so I don't have a lot of money, and I don't have a lot of cars. So I was actually taking my family's different cars and trying to analyze them. So I wasn't able to break anything or remove any part from the car. So the test subjects, which cars was I playing with? I had 5 or 6 of them. The first one, for posterity, is mine, actually. It's a 2006 Volkswagen Polo. What is nice is that you can spend the whole day trying to find some messages on your bus. If your car is too old, there are no messages, so you can take the oscilloscope and try to find them. You won't find them. Anyway, just before doing anything, try to think, is something I'm looking for really in there? The second car is my grandmother's car. It's a Volkswagen Polo of 2013, and the last car I will talk about is my mom's Fiat 500 convertible. It's from 2010. The dates are important because the CAN bus I will talk about just after is quite recent in a way that security on the CAN bus changes greatly from one year to another. So the CAN bus I was playing with on this car was quite different from the 2013 Volkswagen Polo, for example. Okay, so talking with the car. So this is the introduction part. Sorry if people already know about what I'm going to talk about, but I want everybody to be on the same first step. So first of all, an ECU stands for Electronic Control Unit, and it's a small computer that you get all around your car. So there are many of them. You can have at most 70 of them in very modern cars, and they control different parts of it. So you have the engine, the powertrain, the transmission, ABS, stuff like this. And they talk to each other on what we call the CAN bus. The CAN bus is a message-based broadcast protocol. Messages are mostly composed of two important things, which are the arbitration ID, which I will refer to ID from now on. They can be 11 or 29 bits long, and you have data. Data is 8 bytes long on a standard CAN message, but there are on-top protocols that can group messages together to get a bigger length of data. What is interesting is that it's a broadcast protocol, so the collision detection system is based on the ID. The lower your ID, the higher your priority. So very important CAN message will have a very low ID. They will be sent from an ECU that have a very low ID. And less important one will have a bigger arbitration ID. How do you talk to your CAN bus without cutting any wire in the car? For this, there is the OBD2 port. So OBD stands for onboard diagnostic and is the vehicle self-diagnostic and reporting capability. When you are driving, you have a LED that starts to blink on your dashboard saying, OK, something's wrong. You bring your car to your car repair shop, and the car repair guy will just plug itself to this port, which is located around the steering wheel often, and query information using PIDs. So PID is a parameter ID. It means, OK, I want to have information about, for example, the RPM or the speed or the fuel level, something like this. And it can set or reset diagnostic trouble codes. A diagnostic trouble codes means, OK, something is wrong with this part of the car, for example. Here is my setup. So with just a Raspberry Pi, PyCAN to Shield and DV9 to OBD2 cable, I was able to have a full Linux that can understand CAN messages and talk with the CAN bus. So with that, I could just communicate with my car without breaking anything, which is quite nice. What does it look like? So in Python, it's just import CAN. So it's a standard package, Python CAN. You create an interface. So it's socket CAN. So it's like any kind of interface. You just create a CAN 0 interface, and you can communicate with your CAN bus. You create your message. So the data is here. What is important is that the first byte tells how many bytes are important in the message. You can have 8 bytes of data. The number of bytes processed will be this number. So like there it says, OK, there are only 2 bytes of data that are interesting. Just discard the 5 other ones. Here it asks for the first mode. So OBD have different mode. The first mode says, OK, I want the current value of what I'm looking for. And 0xC is RPM, so I want the current value of the RPM. If I put 2 there, it's the second mode, and it asks for the RPM when the last data trouble code was actually set. You have different like that, but what interested me was, OK, what is the current RPM? You create your message. 70F is the classic ID for diagnostic tools, so most ECUs will answer to OBD queries if you have this ID. On 29 bits, it depends on the car. On the Fiat 500, for example, it was this one. You send your message, you get your answer, and that's it. OK, so this was the theory. How do you talk? But how did I actually talk with my cars? So the first OBD answer I was able to get was on my grandmother's Polo. It's quite a recent car, 2013, so there was a gateway, a sort of firewall between the OBD2 port and the actual CAN bus. So when I plugged myself to the CAN bus, I wouldn't receive anything unless I send an OBD query. I would receive my answer, but that's all. Else, the bus would be completely silent. So here are some examples. So this is the one from just before. How can I get the RPM? So this is the value of the RPM. Here I can get the engine coolant temperature, very important. So the idea is that it answers 83, and 83 is 131 degrees. The idea is that you are working with unsigned bytes. So if you want to get a negative temperature, the standards tells you to subtract 40 from your temperature. If you are outside of minus 40 or 215 degrees, you have other problems than your coolant temperature. So, seems to work. OK, nice. So, displaying everything. This was to explain to my grandmother why I was stealing her car for 2 weeks right now. So with this, I'm able to get the RPM, the speed, engine coolant temperature, always very important, throttle and accelerator pedal position, and the elapsed time since engine started. So anyway, kind of graphical. My grandmother understands. Everybody's happy. Right. So right now, I can query standard OBD PIDs. I can have the RPM, speed, fuel level, anything you would want to have on your dashboard. But if you want to get some probably more interesting stuff, you have to go with the constructor-specific PIDs. For example, the steering wheel position, brake and clutch pedal, gearbox status, light or blinkers are constructor specific, so you have to break stuff to be able to find them, or have very good friends with manufacturer, which I haven't. Nice, we can query stuff, mostly. Can we modify anything interesting from OBD? Because still, I don't want to mess with the car by cutting any wire. So first issue, what protocol am I actually talking to? There are on-top protocols like KWP, which is Keyword Protocol 2000, Unified Diagnostic System, ISOTP, the Volkswagen version of ISOTP, like really, and stuff like this. Which protocol am I talking to? Okay, let's just brute force by sending the classic introduction kind of message and try to find for a valid answer. With this, on the 2013 Polo, I could speak UDS. So UDS enables different kind of things like resetting ECUs, which can be quite interesting, query specific PIDs, read DTC information, stuff like this. However, nicer stuff like dump the firmware are only available through security session. And security session on this car requires an authentication through a challenge response kind of algorithm. So here is the example. I would start a diagnostic session, UDS, diagnostic session first, then query for a seed to get through the security session, compute my answer, send it back, the cars compute its own answer, compare, and I would fail, because I would just send the feedback, like maybe they didn't implement a real algorithm, you never know. But, hey, okay, well done Volkswagen, they did it quite well. Actually, the car has a 4-byte seed, which is different at each try. This is important to notice because on Guillaume's car, it's a 2-byte seed, which is always the same. You have more than 3 seconds required between each try, and if you fail multiple times, it will just freeze for 10 minutes if you don't want to remove the battery or that kind of complicated stuff. So, how to break this? Brute force, way too long. Timing attack would be too unstable because of the priority kind of thing, because you can just get delayed by other more important messages, and so it will delay your timing attack. Disassemble the car is out of the question, you know why? And get pieces from a repair shop is tedious. You know, get an ECU, try to recreate the CAN bus around and stuff like this. And I'm broke, so I don't have any money. Okay, so my car, let's sum up. Way too old. My grandmother's car, a bit too recent because of the gateway. My family's car is a Lancia Voyager 2014, so even more recent, but it has Uconnect, so maybe for another time. Who's left? Oh, Mommy? So, my mom has a 2010 Fiat 500 convertible. She loves it. So she doesn't like when I take it, and she even more doesn't like when I try to do stuff with it. So one night, I stole the key. Sorry. And I tried to plug myself in. Oh, it talks. It talks a lot. In 4 seconds, I was able to get 2,000 around message. So it's about 500 messages by second. There is no gateway, so I have a lot of broadcasted message already. They are from few different arbitration IDs, so few different ECUs are actually talking on this bus. When I'm in the car, I try pressing random buttons, and I see that the data evolves. So the nice, funny things to do is to try to understand what each message means. It's quite tricky with CANDump, which is the standard Linux utils, which will just flood your STD out with CAN messages. But Python CAN Monitor helps a lot by grouping messages by arbitration ID. So here I'm in the Fiat 500, and I am driving, actually. And you can see the different arbitration IDs there and the data that is evolving. The two last ones, which are way bigger, are the standard OBD, meaning that, okay, I have a priority that is way lower than the other kind of messages. So, reversing a bit, what can we find? I found the speed 4 times. The values were quite different, but quite close anyway. So was it at 4 different times or at the 4 different wheels? And it was actually at the 4 different wheels, because when I turn, it would change drastically 2 values out of 4. I have the clutch pedal with respect to the accelerator. Am I accelerating while depressing or pressing the clutch? The brake pedal. Are the doors closed? Which one are closed? Is the contact on? Is the handbrake up or down? And this one is quite interesting because it would change every minute. Actually, it's the time and date. So it was 9 p.m. on the 24th May of 2017, meaning that they created an ECU which only job was to send the current time and date readable in hexadecimal format on a can dump. Like this. that was, I found it funny. I have weird sense of humor. Anyway. So, displaying even more stuff, this time to explain to my mother what I'm doing with her car. So, this was a kind of capture I was doing from my school to my home, like I was recording what I was doing in the car, recording at the same time the can dump, and displaying what I could display. So I have the handbrake, start and stop, engine is on, okay, it seems to be. The doors are closed, hopefully. Okay, so this was quite fun to do, actually. Okay. What can we do with that? Can we do something useful for humanity? Can we do maybe something a little bit challenging, or else it's absolutely not interesting? Or can I at least put something on my resume after that, something I can be proud of? Yes. Or we could try to do something completely stupid, and that's what I was aiming to do. So I created CanPad. The idea of CanPad is that with the steering wheel, a brake, and an accelerator pedal, you can drive any car in any video game. So, that's what I did. I take the CAN messages from MobiD, send them back, parse it to a Python client, and float them through uInput to be able to create a virtual gamepad and play in VDrift. So VDrift is an open source racing game that allows one to play on Linux through at least libuinput. So this is the start and stop button that I use as a toggle to send data. And here I'm driving with my mom's car, a car in a video game. So I have the steering wheel, the handbrake, every pedal is quite hard to drive right now. And my official goal is to drift. So first I have to learn how to drive at all. It was actually quite nice when I managed to do anything at all. So you can see the data is only like 16 bytes long. And that's the best drift I was able to do on this game. So I was actually quite disappointed right now. So, features and limitation of this. So the features is what I was explaining right now, but the limitations are that the engine needs to be running, because else I don't have the assisted direction, which makes the wheel quite hard to turn. Also, on a real car, if you release the steering wheel, it will by itself try to match the car's direction, which I don't have, so I would just spend all my time turning the wheel. And the control simplicity going through libuinput limits it to VDrift, because no other Linux game recognized my virtual gamepad as a real one. So I was quite sad, but I really wanted to drift. Oh wait, I created another version, which is CanPad V2. CanPad V2, I just understood that on a real Xbox gamepad, if I plug the Xbox gamepad and don't touch anything, no inputs will be sent. On the other hand, if I put a PS4 gamepad and don't touch anything, it will flood the status of every button all the time. So what I would do is take the Xbox controller, put it on the table, and hijack its port to send data instead of it. So I would have a real plugged-in controller that is recognized by nicer games like like Dirt, and I could send inputs by myself. I changed few stuff like the gas pedal because I had to floor in the real world to floor in the game, which was quite fuel consuming. The steering wheel rotation was adjusted so that it matches rally cars. Like if I turn it 180 degrees, it will turn all the way in the game. So quite nice. And I found the direct command to query unbrake. In the next video, you'll see that when I turn abruptly in the game and I release at the same time the unbrake, they will take a little bit of time before stopping to turn because I have a small delay, but now I have the real input, so it's way easier. So demonstration. So same stuff. Start and stop. I just wanted the music. So anyway, as you can see, it's way easier to play because of the steering wheel, which was adjusted. It's way nicer to drift in this. I can do the crane drift. My brothers were very fond of this. My mother was only thinking about her tires right now. Anyway, sorry. I'll give you the title of the song later if you want. So I can now drift with my front-wheel drive car in any kind of video game, which is almost quite very nice. So, possible upgrades. Yes, there are always upgrades. I could get the gearbox status to put the car on the lift and try to put it in manual, which would be a bit more life kind. And create a better gamepad so that I'm able to race on Mac or Windows, because right now it's only on Linux. Okay, this was fun, but it was actually consuming a lot of gas for nothing. So with Guillaume, we tried to find a way to reduce gas consumption, and that's what he is going to talk to you about right now. Guillaume?
Yeah, thank you, Stan. Okay. So Stan had a little problem about gas consumption, and a friend of us told us about this little Nitro OBD dongle, which is supposed to save fuel. It's sold on Amazon, and the reviews are quite good. So we said, okay, strange, but okay, let's try it. First of all, just a reminder about what is an OBD2 dongle. An OBD2 dongle is a small device that you plug into the OBD2 port of your car. Any recent car has an OBD2 port. You can find it by Googling the model of your car and OBD2 port, and you will find a picture of it. And the interesting thing is that you just have to pull a panel to access to your OBD2 port. And it's very cool because you don't have to take anything apart or whatever. So just buy the thing on Amazon, pull the panel and put it there. That's all. This dongle is supposed to save fuel by reprogramming the main ECU, the engine ECU of your car. And this is done for quite some time. This is known as chip tuning, and you can find it on the internet. It works pretty well. It will break your warranty, but the very interesting thing about this dongle is that it will not break your warranty, because if you remove it, you will go back to factory settings, and this is very new. So it works on any car, well, any recent car, and well, it seems to work really well. Okay, so why did we reverse engineer this dongle? Because it's just an amazing piece of hardware. If you think about it, it works on any car. And it also reprograms any car. So it must contain all authentication codes. Stan explained the challenge and response mechanisms. So this one must contain all of them. It will also contain the reprogramming software for any car of any manufacturer. And this is also just amazing. And I just wanted to have a look at this. And it is able to adapt itself to the way you are driving for a few kilometers, then it will reprogram your engine. And I say, wow, there must be a very smart algorithm inside this very small piece of hardware. And I just wanted to have a look at this software. As I said, also, it also modifies the RAM of your engine. And I was not aware of anything that will be able to do that, because from the things I know about chip tuning, it will change the flash of your ECU. That's why the warranty is broken. But not this one. Not this one. And this is just amazing. I just wanted to have a look at the source code. Well, the binary. Okay, so the first thing about reverse engineering such a piece of hardware is monitoring the CAN signals. To see if it's talking and what it is doing exactly, if it's opening security sessions or not. Well, all this stuff. So here you see in my car, there is the OBD2 port right there. And I use the same configuration as Stan to record the CAN messages, which is a Raspberry Pi here and the PyCon 2 shield. And, well, just often a picoscope to check the signals and a computer to monitor this. The thing is, you just have one OBD2 port in a car, and here. And you cannot plug at the same time the dongle, like this, and the wires for the Raspberry Pi. So we took apart the dongle, and after a bit of reversing the PCBs, we found the CAN lines and the ground, and we just soldered 3 wires on it. And with using this approach, you can reverse the messages sent on the bus. The interesting thing is that as you are plugged directly on the dongle, you will monitor exactly what the dongle is doing and what he's seeing. Just for reference, you just have 3 wires to put in a car to hijack or to communicate on the CAN bus. Those are CAN high, CAN low, and ground. And that's basically all you need to connect to a CAN bus. Just for reference, you can find, on today's cars, you can find many CAN buses in the different parts of the car. So the OBD2 port is just more accessible, but it's basically another CAN bus, just like another one. Okay. So we did 2 measurements. One with basically no OBD dongle plugged in, and the other one with the OBD dongle plugged in. Stan explained in the first part of the presentation that every CAN message is sent by an ECU, and the identifier of the ECU is called the message ID. And the lower it is, the higher the priority is. Here you have the most you have the message with the biggest priority, and here with the lowest priority. And you see here the content of the messages. The thing is, if you look at the list of the message IDs here, and the list of the message IDs here, you can see it's the same list. Basically, it means that no other ECU was talking on the bus when we plugged the Nitro OBD2 dongle. So it means that the dongle basically doesn't speak at all on the CAN bus, and that's too bad, because we say, how is it possible that it works if it's not talking on the CAN bus? Okay. Is it over? Is it just not working? Well, not really. The dongle is advertised as working after 120 kilometers. It will just listen silently to the way you are driving, then reprogram your engine after this small amount of kilometers. So it was still possible that the dongle was not sending anything during the first kilometers, but we couldn't just monitor the CAN bus during such a big period of time. And so we needed another approach, and we chose to reverse the PCB. If you take the dongle apart, you can see two PCBs. The first one here is just connected on the OBD2 port, and the other one seems to contain, well, something. Okay, so this is a picture of the first one. As you can see, there is no component on it at all. It's just routing the CAN wires from there to the second board. So, okay, let's go on. The second one is more interesting. On the front side, you can see, well, a few components, but there are not so many. You have a voltage regulator here, 7805. You have a push button. This diode is part of the voltage regulation, and that's pretty much all you have here. And 3 LEDs. You have 3 LEDs. Okay. On the back side, you can see here there is the footprints of a very small microcontroller, and here it is a picture with before desoldering it. And the interesting thing is that there is absolutely no reference on this device, as if the manufacturer took a special care to hide what was inside. And this is not so common because usually you can find a reference on a chip. So, yeah, also there is no CAN transceiver on this device. Yeah, it's strange. What is a CAN transceiver? A CAN transceiver is a piece of hardware to translate the signals from the CPU, which are basically UARTs, into CAN signals, which are CAN high and CAN low. This is a differential pair, and that's also. But this device is not just about adapting the signals and electric conversion. It's also about real-time monitoring and checking. Stan explained before that in each frame you got a CRC and an error bit, and if there is a transmission error on a frame, any CAN transceiver has the duty to assert the fault in real time. So it just has a few microseconds to compute the CRC in real time and say, okay, no, you just have to discard this frame. So basically 2 tasks for this one: electrical signal conversion and checking in real time. Okay, so you have no CAN communication, no CAN transceiver. Okay, smells weird. A few guys told us, yeah, but maybe it's possible to do that in software because you see those are just signals, and maybe with an ADC and so on you can do that in software. I put a link if you're interested here for a Stack Overflow discussion, which is very interesting. And a few guys say, okay, yes, it's possible to do that in full software. So you basically don't need a CAN transceiver. The thing is, as the CAN transceiver has to react in real time, you have to have a very fast CPU to do that in real time. And the guys on Stack Overflow say, okay, it's possible, but at a very low speed, like 10 kilobits per second or something like this. But on a real CAN bus, on a real car, the speed is more like 500,000 bits per second. So it's not the same order of magnitude. So, okay, and then some of the guys said, okay, maybe there is some CAN transceiver inside the chip. And I say, okay, guys, it's just a small SOP8 chip. There is nothing there, just a small microcontroller. But just to be sure, and because we like to decap chips, I asked my intern to do that because, you know, there are toxic fumes and things like that. So here is Stan. In my garden. And well, it was pretty, it was the first time I did that, and with Stan also. And the thing is, it's pretty easy to do that, but if you want to do it, just be careful because it's very dangerous stuff. You can buy it on the internet. It's very cheap. And what do you need? You need a cooking plate here to produce some heat. Crème brûlée, or just the ceramic plate. You pour the sulfuric acid in it, you wait for it to be hot enough, and that's all. Basically, you just throw your chip in it and you're done. Just wait 10 minutes and that's all. So again, if you want to do it, just do it because it's fun, but use protections because it's very dangerous. Okay, well, here is the result. I put a real CAN transceiver here, and this is the chip you have in the Nitro OBD2 dongle. Some of you will recognize the basic structure of a microcontroller, of a small microcontroller. Here you have the CPU logic, here you have the memory banks, and some glue logic there, and that's pretty much all you have there. The interesting thing is that this does not fit into this. So definitely there is no CAN transceiver into the Nitro OBD2 dongle. The other thing I would like to show is, if you look at this, we said before that the Nitro OBD2 had to contain a database for all authentication algorithms, all the way to reprogram any car on the market and so on. And this is all the flash you have inside. I was expecting at least a big chip of flash, but there is nothing here. So basically it just looks like a tiny microcontroller, like an Arduino or something like this. And but I really wanted to know what chip it was. So we have a game at the office. It's just looking for Waldo, and because the chip manufacturer like to write a chip reference inside that chip, and well, there is something here. If you look at the chip, the big magnification power, you will see this, and this is the chip reference. Unfortunately, I could not find any reference on the internet about this chip. I asked a few friends on Twitter and so on, but nobody could find it, which means, well, I don't know, this is not a big chip, very well known. If you know what it is, just tell me, send a mail or whatever, and we'll take the microphone during the question and answer session. It will be nice. So, just to sum up this part, this dongle is very nice, but there is no CAN communication. It does not contain any CAN transceiver. It has not enough power, CPU power, to emulate a CAN transceiver in full software. And the most important thing is that it has no flash in it to contain the database, to reprogram any engine and so on. But the links are blinking very well, so yeah, if you really want to reprogram your car, use something else. Thank you. I would like to invite all of you, if you are interested in car hacking, to try and put some OBD cable into your car, because it's very easy. You just have to pull a panel to get access to your OBD ports. You will just need a Raspberry Pi, CAN shield, and a cable, and that's pretty much all you need. Just a few words. So you don't need to take anything apart, so it's pretty easy. You can do many interesting things just by using the OBD2 port of your car, like fuzzing and so on. But please be careful. You can hurt yourself or break your engine if it's running. So if you do some fuzzing, please stop the engine before.
Yeah, because as you saw at the beginning, I was actually recording CAN data or querying stuff while I was driving, which was the stupidest thing I did from the whole analysis. I was able to disengage ABS by fuzzing too, stuff like this, because they have some systems that if they receive too many invalid kind of messages, they will just shut off. So I was able to disengage stuff like this. So yeah, if you are doing stuff like this, just don't drive while doing it, for example. That's the kind of stupid mistake you do when, disable the airbags.
That's very important.
You never know.
Well, thank you again, and yeah, if you want to speak with us, you're more than welcome. Thank you.
Thank you, indeed, guys. Black Hat normally skip the car hacking talks. This time it was really amusing, and I'm happy that that I didn't do that. We have a lot of time for questions. If you want to line up, there's one over there, or two over there, one over here, and one over there. Are there questions from the audience? Signal Angel.
So people on the stream are wondering where they can find your software and whether you contributed any signals you found to the OpenDBC project that is collecting signals from the CAN bus.
I haven't really heard about this yet.
Oh, you have.
So right now, not that much, but I will take a look. We will take a look at this after this. Sorry.
Mic 1.
I was wondering, you try to reverse engineer to get into the secure mode so that you can access all the ECUs.
Sorry?
You wanted to reverse engineer this challenge response authentication.
Yes.
Why did you not try to reverse engineer the diagnostic software that is used by the dealers?
Because this, in French, we call this valise with luggage, and it costs, if I recall correctly, about 5,000 euros by car manufacturer. So we went to a garage and asked the guy, can you lend us your valise? And he just laughed at us because no, he didn't want to. But there are some partnership you can have. There is a group of manufacturers that offer that kind of information if you pay every month a very huge sum of money.
I think you can, for like €6, you can use it for an hour.
I haven't heard of it. I just saw big numbers and I told myself, okay, I'll find another way.
Okay.
Microphone 3.
Great presentation, thank you very much. I was just wondering how much more work is needed to actually control your car with an Xbox controller?
I was asked this question before. Not that much, if you find the right guys with the right amount of knowledge. No, the idea is that you'll get, of course, you'll have to find a way to control the car from the CAN bus, which is not something that easily done, because for all I know right now, the CAN bus I was on was only used for broadcasting information, not really using this information for real-time data. We actually try to find some way to know how the ECUs interact with each other with Guillaume's car. So the idea was that we go to a field. I am on the passenger seat, and he would just tell me, okay, try to find the ABS ECU. I will brake very hard, so he was driving fast, braking. I was just checking to find which ECU would actually send something different. And after, we tried to recreate some messages, but without a lot of luck. So from the CAN bus, I don't think that's quite possible, but they did it. Nissan did it like 2 months ago with the GT-RC. They created a Nissan GT-R that is actually controlled by a gamepad controller, but they have a full robot in it just controlling the steering wheel and pedal, so it's quite easy when you have money. Yeah.
Microphone 2 in the back, please.
Okay. Hi. Nice talk. Thank you. First of all, don't play around with the airbags, please. I tried to reverse engineer my old Mitsubishi. I'm a passionate Mitsubishi driver. Please don't drive around. You get hurt really hard. Just don't do it. Okay. My real question is, did you try to reverse engineer cars with an older bus than OBD ever? Because mine is from the 90s.
Yeah. No, I didn't, because I had my handful already with the OBD. To be honest, before this analysis, I hadn't touched any kind of bus or any kind of car systems ever, so I was really discovering everything from scratch. So I just focused on the OBD port and the CAN bus and stuff like this. But I know there are a lot of different stuff. Valasek and Miller already did different kind of attacks on the Jeep, for example, or the Prius with different buses. So I I ought to be looking at them, but right now, no, I didn't do anything else from the OBD or CAN bus.
Is there another question from the internet? Okay. Otherwise, mic 1.
Just
yeah. Okay.
Sorry, just one sentence. I guess because of the Mitsubishi stuff, you mentioned the car of your parents or so. I guess we should talk about the Lancer. Okay.
Okay. Very okay. This.
Mic 1.
Thank you. There are some other buses like EtherCAT or FlexRay in other car manufacturers. What about hacking them? So you also said you already said that maybe you will try it in the future, or? Well,
quite the same answer. I read the car CAN book, so I just have a little grasp of the other kind of protocols and bus and stuff like this. Right now, I didn't do anything. I am planning on trying different new buses, but right now, I haven't touched them. I can't really answer more honestly than this. I don't know. I'm sorry.
The other thing is that on the OBD2 port, you just have access to the CAN bus. And as far as I remember, the Flex bus, the Flex bus is internal and dedicated to high-speed buses. So it's not as easy to plug yourself onto this bus because you have to open your car and take things apart and stuff like this. But it's definitely interesting to look at it also.
Sorry.
Okay, another question from the 3, please.
Oh, it's 4, okay. So just a little hint, OBD2 is actually just half of the fun. So you should definitely remove your car radio and check if there's a CAN bus behind that. I know for BMW you have it. And there, of course, it's much easier to control all of the fancy buttons that you have in your car, like window and wipers and all that stuff, because that's completely unencrypted, and so can simply listen on this and also send your own commands.
Okay, so check the other CAN bus in the car, right?
Yeah, it's mainly the car radio, because you don't have to cut anything. Just plug it off, take an adapter, and put your own wires on that.
Thank you. Maybe another talk.
I heard we have one question from the internet now, and then the one.
So there's a person from the darknet who would like to leak you original diagnostic software for that kind of hardware, and the person wants to know whether you would be interested in that.
I haven't heard the end of the sentence, but the beginning.
Would you be interested in a software leak of original diagnostic software? Actually, you don't have to answer that because the person is outside, but if you want to say something, you can.
You have my Twitter.
Yeah. Okay, your question, please.
Okay, well, first, thank you for your very inspiring speech. Luckily or unfortunately, I don't own a car myself. Otherwise, well, what I wanted to say was, you now had your hands on a few Volkswagens. If you could choose a car yourself, what brand would you like to monitor?
To monitor. Actually, what I wanted, but I haven't taken the time right now, was to play with the Lancia, the big monospace, because it has Uconnect. And as far as I remember, it was one of the attack vectors Miller and Valasek used in the past. So I think I would go with the one with full features everywhere and remove parts to be able to get to the fun stuff. So I would take one with a lot of electronics, not too much because it's expensive, but at least a bit of electronics so that I could remove stuff and do interesting and nice stuff.
Thank you.
Okay, and another one over there.
Hi, thank you, and I enjoyed your talk. I think I read you already online, or I read something about doing that, what you've done. It's really fun. Just a few corrections to the last part. The transceiver does not do any error correction. It's just a transceiver. And there are chips actually available which have a Cortex M0 and the transceiver on chip for a few bucks.
Okay.
So those chips exist and are used in automotive.
Okay.
And just for your fun for next year, choose the right car. Just appending that question from that girl. There are car manufacturers who can do networking and who can't do. And let's say you are currently with the right brands, like the Italian.
Okay. Thank you very much. I have way more information than when I started this talk, which is not what I expected at first.
I would say final question, Mike 1.
Very small question, but did you consider lifting the front wheels instead of starting the engine to make it steer easy?
Yes, I put it on, how do you, parpaing, the block of cement you find in the, but it's not the easiest part. What would be easier, what was done was to put cardboard under the wheels to make it easier with a little bit of oil to turn. But yeah, to be able to play without the engine turned on and with the assisted direction kind of like, putting the car on a car lift would be the safest way. Because just putting the front wheels, I wouldn't see anything from the windscreen, which would be a bit disappointing. But yes, indeed, I plan to put it on a car lift soon. Sorry, Mom.
Anyone who didn't get the chance to pose the question on stage, I'm sure that the speakers can be approached next to it. Thank you again for being here and Drift On.
Thank you very much.
Thank you.